In this video, we will be understanding three important concepts in trigonometric functions. First is understanding what is the definition of a radian. Radian is a unit of measurement of angle. Then we'll also find what is the relationship between the arc length in a circle and the angle formed by the arc at the center of the circle. Also, once we understand these two, we will apply this understanding to finding the values of sine, cosine and tan at 0 and 90 degrees. So let's get started. Now let us try to understand what is the definition of 1 radian. So radian is the unit of measurement of an angle, and let's consider this circle as shown. We have the radius of this circle as r. Let us mark a point P on the circle where AP, which is the arc formed on the circle, is also equal to the radius. When this is the case, when the length of the arc and the radius both are equal, the angle formed at the center of the circle, which is AOP, this is called 1 radian. So this is the definition that you should remember. Please take a note of this. It will be useful in the future concepts. Now let us try to understand the relationship between the length of the arc and the angle formed at the center of the circle. So as the length of the arc increases, so suppose the arc was cut at point C, the angle formed here between line OC and OA, this will be small. Now if you move the point C to point B, the length of the arc also increases and also the angle formed also increases. So that means length of the arc is directly proportional to the angle formed. So now what we can write is length of the arc AB divided by length of the arc AP is equal to angle formed by the arc AB, that would be AOB, divided by angle formed by arc AP, which is AOP. This is because they are directly proportional. We can take a ratio of this. Now AB is considered as S, AP is considered as R, because by definition what we have done is to find the value of 1 radian, we have to cut an arc which is equal to the radius. So AP is equal to the radius of the circle. So let us consider it to be R. Now angle AOB, let us consider it as theta, and angle AOP is by definition 1 radian, because AP, length of arc AP, is equal to radius of this circle. So we can write it as 1 radian. Now if we rearrange this, we get that length of the arc is theta times r. So this is one of the very important relations we will use in future determinations of angles at 0 degree and 90 degrees. Now let us try to understand how we can identify the values of sine and cos using coordinates. Let us consider a unit circle. When we say it's a unit circle, that means the radius is 1 unit. It can be 1 centimeter, 1 meter. It can be any unit of measurement. Let us mark a point P such that the length of the arc is x. Now we know that theta, which is the angle formed here, theta is equal to S by R. So here we know that S is equal to X and R is of radius 1. So theta is also equal to X. So now we can consider the length of the arc and the angle formed at the center both to be X. Now to understand the coordinates of cosine and sine, we have to actually have a right angle so that we can apply the definitions of cos and sine. So let us extend this point P to the x-axis at point M so that this is a 90-degree angle and a right angle triangle is formed. Let us consider this point P a coordinate to be a comma b. It can be anything. So what is the definition of cos? So if we apply cos x, that would be adjacent by hypotenuse. Here adjacent is OM and OM's length is a, because that is the coordinate a comma b. So a by, and hypotenuse is 1 because it's a unit circle. So cos x would be equal to a. Now what would be sin x? So definition of sine is opposite by hypotenuse. What would be the opposite side of x? It would be PM, and the length of PM is b because that's the y coordinate. So b by hypotenuse is again 1. So sin x is b. Now what did we understand here? We found that coordinate of x is cos x and coordinate of y, which is b, is sin x. So point P can be written as cos x comma sin x. So this is the coordinate that we found out at P. Now we know that x comma y, which is the coordinate, is cos x comma sin x. Now let's try to find the value of cos 0 degree. So when we say cos 0 degree, that means x should be 0. That means when point P is again brought back to point A, that is when the angle formed here, when P and A are at the same point, that is when the angle formed is 0. So when angle formed is 0, what would be OA? What would be the length? OA is equal to OP. And what would be the length of OP is equal to OA? That would be equal to 1. So cos 0 is 1. Now what would happen to sin 0 degree? Sorry, let me fix it. So what would happen to sin 0 degrees? Now when we say sine, that is the y coordinate, and sin 0 would be equal to 0. So this is how we find cos 0 and sin 0. Now let us try to find cos of 90 degrees. When we say cos 90, that means the angle x should be equal to 90 degrees. That means point P should reach point B. So in that case, what would happen to the value of A, which is the x coordinate? A would become 0. So cos 90 degrees is 0. And what would be the value of sin 90? When P reaches point B, the y coordinate is equal to 1. So sin 90 is 1. Now if we know the value of cos and sine at any degree, we can easily find tan. So tan 0 is sin 0 by cos 0. So that would be 0 divided by 1, which is equal to 0. Now same way, what would be the value of tan 90 degrees? That would be Sine 90 divided by cos 90. So sine 90 is 1, cos 90 is 0, and this is undefined in mathematics. So 1 divided by 0 is not defined. So tan 90 is not defined. So this is how we can find the value of cos, sine and tan at 0 and 90 degrees.